Hi guys! Today we will solve an optimization question from the 2025 HSC Maths Advanced paper. Honestly, it is really a classic one and it looks complicated, but it's not as tricky as you might think. Now, it's a 5-mark question. It should take about 7 minutes in the exam because about 1 mark is 1.5 minutes. And when you practice at home, try using a timer. Practicing under exam conditions is really important. Okay then, let's do this. Here is the question. A piece of wire is 100 centimeters long. Some of the wire is to be used to make a circle of radius r centimeters. The remainder of the wire is used to make an equilateral triangle of side length x centimeters. Part A. Show that the combined area of the circle and equilateral triangle is given by, there is the formula, and that's the 2 marks. Part B. By considering the quadratic function in part A, show that the maximum value of a of x occurs when all the wire is used for the circle. That is 3 marks. Okay, let's start. Now, this is my thinking space. In my head, I'm thinking circle with the radius r and the equilateral triangle with x centimeters as their side. And of course, it's equilateral, so it's going to be 60 degrees. The information says I have 100 centimeters long, the wire is. Thinking of perimeter here. So the perimeter of circle equals 2 pi r. The perimeter of triangle is 3x, because x plus x plus x is 3x. Now I had 100 as a total, so I'm going to write 100 centimeters equals 2 pi r plus 3x. And then when you look at the final area, there is no r terms in there. It's all in x terms. So I can predict I need to replace r with x. So I'm going to make this r the subject. And make it that as number 1. As you can see, it's already looking a little bit like a of x, which is good. Now I'm going to put total area is area of circle plus area of triangle. Now area of circle will be pi r squared. Area of triangle, when I look at the triangle, it's non-right angle triangle. We will use sine rule. Half times x times sine 60. Now also I'm going to replace r with the number 1 equation there. So pi and I'll tie this one up a bit times. Now you have to use exact value on that one. So it'll be, I will look at times now I'm going to cancel this, and what do I have? I'm going to put root 3 over 4x squared to the front so that it will look like what we want to achieve. And what I have left is I think we are nearly there. The final answer, I'm looking at what I have to achieve. I've got quarter as my common factor, put it out. What do I have left? And root 3x squared plus 100 minus 3x all squared over pi, just like the one that what we have to show. So I'm going to say as required. So this is my thinking. When I put that in the paper, this is what it looked like. Okay, let's mark this one. So where the 2 marks gonna go? The 1 mark, it should go here. The correct expression for r in terms of x. So that's 1 mark. And then, of course, the rest of the working out is 2nd mark. So there's 2 marks there. Now, let's have a look at part B. Now, when you look at this question, straight away, some of you might think, oh, I need to do my differentiation here because it says maximum value, but you don't need to. Let's have a look at this. Now, what does that really mean by all the wire is used for the circle? No wire is used for triangle, which means x has to be 0. Okay, keep that in mind. Back to my thinking space, I'm going to bring my quadratic function from part A. So I'm just going to write this down. A of x is a quadratic with, if you look at these, you know that this quadratic function has a positive coefficient of x squared, because that's a positive. When you expand this one, it's going to be 9x squared, but positive. So it's going to be positive. Therefore, it's going to be minimum. Why? Because it's a concave up, right? And you're going to get minimum value. So where can we get a maximum then? The maximum occurs at end points. So I want you to think about this. We got this graph here. It's concave up. It's going to be minimum. And here, when x equals 0, could be maximum point. I made it x equals 0 as a maximum because that's what we had to prove. I'm thinking if I can find x values of the endpoints, and if I can compare or prove that when x equals 0, it is a maximum value, then I'm answering the question. So I need to find x values. We know that one of them is 0, and we just have to find the other one. I have to find the domain. Now, perimeter of triangle was a 3x, and perimeter of circle is 100 minus 3x. Now, I'm going to use perimeter of triangle. So it goes from 0 to 3x to 100 because the total was 100 centimeters. So I'm going to divide it by 3 on this. It'll be 0x 100 over 3. So here is my x values. When x equals 0, when x equals 100 over 3. So here it's 100 over 3. So let's compare them. So when x equals 0, I'm going to put 0 into the a of x, 1/4, 0 plus 100 squared over pi. Put that in your calculator straight away. You will get 796 centimeters squared. When x equals 100 over 3, I'll get √3 times 100 over 3 squared plus 100 minus 3 times 100 over 3 squared all over pi. Now that's going to be 0. So the whole thing will be 0. So what do I have left is 1/4 times √3 times 100 over 3 squared. And if you put that in your calculator, you will get 481 centimeters squared. We actually proved it. When x equals 0 is bigger than when x equals 100 over 3. So my final answer should be the max value of a of x occurs when all the y is used for the circle. So now I'm going to show you what it looks like on the HSC exam paper. Okay, so where these 3 marks gonna go? Let's have a look. This part is very important, this 2, that quadratic with positive coefficient of x squared is concave up, therefore it's minimum, and therefore maximum has to occur at endpoints. So that will earn 1 mark there. And then of course a second mark will go when you compare them. So you'll get the comparison there. And then the final mark will be the conclusion. Obviously, you're not going to get any marks just writing that part without the explanation. If your solution looks like this, you've done the beautiful first derivative and the second derivative, and then you realize, oh, it's a minimum, not maximum. And then you just, oh, I don't know what to do. I just left it. So you probably get 1 mark for it out of 3. And then somehow you found out, oh, if this is a minimum, maximum occurs at endpoints. And then you find the domain of it for endpoints. And then some reason your calculation is not correct. So that will give you 2 marks. Wrong calculations but correct reason can earn you 2 marks. That's what I think. Okay, so this is the end of question 26 solutions. Hope this was helpful. So I'll see you next time. Don't forget to subscribe. See ya.